Hi, this is Miss Park, and this video will be about solving quadratic equations. Solving quadratic equations is a topic that's first introduced in grade 10, but we use it quite a bit in grade 11. So just to remind you, I'm just going to go very sort of high level here and talk about what it means to solve a quadratic equation. If I have a quadratic function, the quadratic function has, this particular quadratic function has two x-intercepts, okay? The formula for the quadratic function, the equation, is y equals ax squared plus bx plus c. That's in standard form. The quadratic, so this is the quadratic function. The quadratic equation that matches up with this is ax squared plus bx plus c equals 0. That's the quadratic equation that goes with it. And solving the equation means finding out where does this parabola have x-intercepts. So where is the value of this function equal to 0? So this is what we're actually finding. So when we solve this equation for x, we are actually finding x-intercept. Now, does every parabola have x-intercepts? Okay, in other words, does every parabola or does every quadratic equation have solutions? So that's going to be something that we'll address at the end of this video. Okay, but for now, this is what we're going to try to do, and I'm going to show you a number of algebraic ways to do it. Okay, the first method is called solving by rearranging. And so let's say I have an equation in vertex form. So let's say I have an equation that looks like this. Okay, an equation, and this part over here is written in vertex form. So we know that the quadratic equation in standard form looks like this, right? Very often when we get equations that don't look like the standard form, we'll just expand and simplify and then make it look like this form and then use some of the methods that we're going to see. But this particular form, a vertex form, is actually an easy way to isolate the x, which is what we want to do. We want to solve for the x. So what we'll do is we're going to move things away from the x. So we're going to undress it in a way, or isolate it, okay? So first thing I'll do is I'll move the 3 to the other side. And the idea is that I'm trying to get x alone. I can see that x is in a bracket squared, but the actual x, there's only one x in here. If I expanded it, I get x squared and x, but right now I only see one x, so I'm going to work with that. And then to isolate the x, I'm going to get rid of everything around it. So I'll divide by 2 both sides. And now I have a square, so I can actually get rid of that square by taking the square root of both sides, recognizing that when I take the square root of the right side, I'm going to get plus or minus. I'm going to get 2 answers. Now, if we want to get fancy, we can simplify the other side because we know about radicals. So we can rationalize the denominator on the other side by doing this, by multiplying it by the fake 1, because we learned about radicals. And so x minus 5 is going to equal to plus or minus 3 root 2, plus or minus root 6 over 2. And so just x is going to equal to 5 plus or minus root 6 over 2. And now we have two solutions. So if I was to draw this out, this is a parabola with vertex 5, negative 3 down here, and it opens upwards. We can tell because of the positive a value. And so what we've just found are the two x-intercepts. Okay, and I was able to do it without expanding this bracket. Okay, so that's solving by rearranging. Let's do solving by factoring. So I'm going to go to our plain old ax squared plus bx plus c. Okay, and I'll give you the parabola the quadratic equation 2x squared plus 7x plus 3. All right, so what we'll do over here, I can't just move the 3 to the other side and get, okay, let me just show you what happens. If I just move the 3 to the other side and try to solve for x, I can't because I have here an x squared term and an x squared term. And there's no way I can isolate the x because there's two different types of terms that contain x. So this doesn't work, okay? But what I can do is I can factor this. So use your favorite form of factoring, decomposition, crisscross, area models, whatever you like, and try to factor it. So I'll just pick one. I'll use my trial and error method. So 2x squared would be 2x and x. The 3 could be 3 and 1. So if I expand this, I'd get 2x squared plus 2x plus 3x plus 3, but that does not add up to the 7x. So I know my 3 and 1 are not in the right place. Let me just take them out. So I'll put my 1 here and my 3 here, and hopefully that's better. So now it's 2x squared plus 6x plus 1x plus 3, and that does equal the above. Okay, and now what we have is we have a situation where we've got two items multiplying together to give 0. This bracket times this bracket is 0. And so when we think about numbers, when would you ever multiply two numbers and the answer is 0, right? When can that ever happen? And that can only happen if one of those numbers is 0. So we actually have two possibilities for this product to be 0. Either the first bracket must equal 0 or the second bracket must equal 0, right? That's the only way I would have two numbers multiplying and the answer is 0. Well, in the case of the first bracket, I can solve this. So 2x would be -1, x is -1/2. In the case of the other bracket, I can solve this. X would be equal to -3. So I get my two answers. So once again, I don't know where the vertex is over here, but I know that one of the x-intercepts is at -1/2 and the other x-intercept is at -3. I could sketch it because I know that it opens upward. I could sketch the parabola as being like this. Oops. But the point is that I'm able to figure out what the x-intercepts are, and those are the solutions, okay, to the equation. So let's do another thing. Now, let's say it didn't factor. So let's suppose that I had 2x squared plus 7x, and instead of 3, I had a 2. Okay, and you can try and factor this, but it's not going to be factorable. So we had something else. We had a tool that was introduced in grade 10 called the quadratic formula, and the quadratic formula looks like this: x equals -b plus or minus the square root of b squared minus 4ac over 2a. And you might have been taught this with a song or a little jingle or a poem or a little story. But whichever way you were taught it, you are responsible for knowing this formula. We're going to use it quite a bit. So what you do with this formula, recognizing that this is ax squared plus bx plus c, you put your values into the formula. So we have -7 plus or minus the square root of 7 squared minus 4 times 2 times 2 all over 2 times 2. All right? And so x is equal to -7 plus or minus. Now, under here, this is 49, and 4 times 2 times 2 is 16. 49 minus 16 is 33. So I have -7 plus or minus the square root of 33 over 4. And that is as simplified as I can get it because the root 33 can't be simplified, right? We learned about simplifying radicals, and there's nothing I can do with this root 33. And so that's going to stay like that, okay? If we go back to the previous page and try to do this same question, but with quadratic formula, we would get the same answer. So I'm just going to use different pen. So x is -b plus or minus square root of b squared minus 4ac over 2a. And if I put my numbers in there, I'm going to get -7 plus or minus square root of 7 squared minus 4 times 2 times 2. Times 3. 4 times 2 times 3 over 2 times 2. All right, which is -7 plus or minus. Now, this is 49. 4 times 2 times 3 is 24. 49 minus 24 is 25. Okay, and that's going to give me a whole number because the square root of 25 is whole number 5. So I have two options. One of the roots is going to be x is -7 plus 5 over 4, or the other one is going to be x is -7 minus 5 over 4. This first one is going to give me it's going to give me negative 2 over 4, which is negative 1/2. The second one is going to give me negative 12 over 4, which is negative 3. And you can see it's the same solutions as with the factoring. Okay, so generally we don't use quadratic formula if the thing factors. It's much prettier to actually do the factoring. We use the quadratic formula when the equation doesn't factor. Okay, even though it will always work in all the cases. Okay, so how many solutions would you expect? All right, so if you have a quadratic function that looks like this or like this, you see that there are two x-intercepts. So in this case, you have two solutions. All right, if you had a quadratic function that looked like this or like this, where the vertex sits on the x-axis, then you have only one solution. And if you have a quadratic function that looks like this, that is opening away from the x-axis, then you have no x-intercept, so you have 0 solutions. Okay, now just for a little bit of terminology, I am using the word solution and the word x-intercept interchangeably. So the x-intercept of a quadratic function, so of the parabola, I'm using it the same as the solution to the quadratic equation. Okay, it's the same thinking. Okay, if you drew it out, it would look like x-intercepts. If you just wrote the equation, it looks like they're just solutions to the equation. And another word you might see is roots. Okay, the roots is the same, is referring to the same thing as the solution and the x-intercept. So how do you know how many it will have? And the cue to know how many it will have comes from the quadratic formula. So in the quadratic formula, so I'm just going to write it out for the third time. So hopefully by now you have memorized it. And if not, you need to memorize it. Okay. If I give you a function or an equation where this stuff under the square root sign is negative, then when you go to apply the quadratic formula, you will have the square root of a negative number, which is not real. We talked about real numbers. That's not a real number, which means that it's not graphable, which means that if the stuff under the square root sign is negative, we will not be able to find the x-intercepts because we don't know what the square root of a negative number is. So in the case of there being 0 solutions, you will find that this stuff under the square root sign is negative. We cannot calculate it, and that's why we can't find x-intercepts. If the stuff under the square root sign is 0, then our two solutions will be negative b plus 0 over 2a and negative b minus 0 over 2a. But plus 0 and minus 0 is the same thing. It doesn't change anything, right? If I had negative 7 plus or minus the square root of 0 over 4, well, that's just negative 7 over 4, right? So that's just one solution. So in this case, there are two solutions, but they're both the same. So that happens when b squared minus 4ac is equal to 0. And that means that even though you come up with two numbers, it's the same number. And there will only be the one x-intercept on the graph. And finally, the last case is if there is a number in here that's greater than 0, then we can take the square root of it, which means that I'll have two answers. I'll have negative b plus the square root of that number and negative b minus the square root of that number over 2a. And that's when you get two distinct solutions like this, two different solutions. And that will happen when your b squared minus 4ac is greater than 0. So if I give you a quadratic equation and I ask you how many solutions does it have, you don't actually have to go and solve it, right? We can just figure out how much is this b squared minus 4ac and decide. If that's going to be negative, we know we won't be able to solve it, so it has no solutions. If it's 0, we know that our two solutions will give us the same answer. And if it's greater than 0, then we know that we are going to have two different answers. The mathematical word for this stuff that's under the square root sign is called the discriminant. Okay, and the discriminant, d, big capital D, is equal to b squared minus 4ac. So the discriminant helps us to discriminate between how many solutions we're going to have. Let's do a quick example using the discriminant on the next page. So I'm just going to ask how many solutions. Okay, and I'm not asking what are the solutions. If I asked what are the solutions, you'd have to solve it. But I'm not asking what are the solutions. So let's just go 10x squared minus 8x plus, I don't know, 15 equals 0. Okay, so all you have to do, you don't have to solve it, you just calculate the discriminant. The discriminant is b squared minus 4ac. This is your a, this is your b, this is your c. So b squared is negative 8 all squared minus 4 times 10 times 15. And that's 64 minus this really big number. I guess it's 600. Doesn't matter what the number is. The point is that the discriminant is going to be less than 0. And if the discriminant is less than 0, that means the stuff under the square root sign is negative. We cannot calculate the solution. So therefore, we say there are no real solutions, or you could say there are no real roots. Solutions, or you can say there are no real roots, okay? And that's it, and that is your solving quadratic equations. So please practice those. Sometimes you've got to rearrange the equation, so you'll notice in the homework questions, sometimes you have to rearrange it so that your question always looks like ax squared plus bx plus c equals 0. So it might take some manipulating of the equation to get it to this form. Okay, unless it's vertex form, in which case you can solve by rearranging if you like. All right, and that's the end. So good luck. Thanks for watching.